Hello everyone, welcome back to my YouTube channel. Today we are going to look into another important algorithm, Floyd's algorithm, which is again a graph algorithm and which is similar to the Warshall's algorithm that we had discussed earlier. So we are going to find the transitive closure, that is, if there does not exist a direct edge between some nodes, that is A to C, we have to find the minimum. So there will be another edge from here and here, so we'll find if this is minimum or if this is minimum. So we have to reach from A to C, but through which A to B to C or A to D to C is minimum, we'll check. Let me take an example. The example graph is, I will take the simple one. So the inputs are n number of nodes, the graph, and in output we again get a graph with possible transitive closures. So it should be a weighted graph. The input should be with weights, that is, let us take it as 5, 3, 1 and 10. So while giving the output, we have to give it through adjacency matrix. So the adjacency matrix becomes 0, 5, infinity and 10. 0 because there does not exist a self loop from 1 to 1. 1 to 2 is 5. 1 to 3 there is no direct edge, so infinity, and 1 to 4. So 1 to 4 there is an edge with weight 10. Please make a correction, that is 1 to 4 there was an edge with weight 10. So from 2 it is infinity, 0, 3 and infinity. From 3 it is infinity, infinity, 0. So this is the input matrix. So we have to make a graph such that we have to replace these infinite values with the shortest path possible if it exists. So we'll just do it directly. So from 1 to 1 there is no edge, there is no self loop, and same with 2 to 2, 3 to 3 and 4 to 4. So from 1 to 2 there exists a direct edge and there is no other possible edge which is smaller than this. So we'll write 5. In this place of infinity from 1 to 3 we have one possible way, that is 1 to 2 and 2 to 3, that is 5 plus 3, 8. From 1 to 4 we have directly 10, and if we go from this side, that is 5 plus 3 plus 1 which is 9. So minimum of these two we have to take, that is 9. So even though there exists a direct edge 10, if there exists another possible path which has a minimum weight than this, then we'll consider that. So from 2 to 1 there is no direct edge, so infinite remains the same. From 2 to 3 direct edge. From 2 to 4 it is 3 plus 1, 4. From 3 there is no direct edge to 1 or 2, and to 4 it is direct edge 1. From 4 there is no possibility of going to any other edge. So this is the output we get. So the formula what we use is we have to choose the minimum of a of I of j or a of I of k plus a of k of j. So I comes first and j comes at last. This k value is the iteration, so that runs from 1 to 3. The I value holds rows, j value holds column, or the other way around, and k holds the iterations value. So I of j or I of k plus k of j. The minimum of these will be taken as the weight that we write here. For example, 9 here. So let us look into the code now and then run the same input in the console and see the output we get. Into the code now, I've already written the package and the import statement. Let us start with the code. The class name has to be same as the file name. So we have to take the inputs that are the number of vertices and the graph. For that we need to create an object for the scanner class. Then we'll give the user prompt, that is enter number of vertices or nodes, that is n, which is an integer. We have to create a graph, 2D array graph of size n, and we'll ask the user to give the values for the graph. So for I0 to less than n, and for j0 to less than n, we will take the input. Then we have to send this graph and the number of nodes to this Floyd's method, which we will be defining it now. Here we'll be having 3 for loops that runs from k, I and j, the same way we discussed. The k value is the iteration. So for that, we are defining the first for loop that runs from 0 to n, and then we need 2 for loops that runs in the rows and the columns. So we'll be writing the condition here. If g of I of k plus g of k of j is less than g of I of j, then we'll make g of I of j as a of I of k plus g of I of k plus g of k of j. So if this value is less than this value, then this value becomes this. So it is as simple as that. And after all the for loops, we have to write the printing statement. Again, we'll have two for loops to print because it is a 2D array we are printing. In the output also we get the 2D array. We have to print the g of I of j, g of I of j, and some space between that. After one for loop, we'll be printing a line. So this is the Floyd's algorithm program. Let us run it and give the same input. So the number of vertices we discussed was 4. The matrix was, so wherever it was infinity, we are giving it as 999. So this is the output we get 0589, infinite 034, infinite infinite 01, and from 4 there was no possible ways that we could find. So I hope you have all understood this Floyd's algorithm. Thank you all for watching. For more such videos, please subscribe to my channel. If you haven't watched the similar Warshall's algorithm, I'll put the link in the description. Please do watch that also. Thank you all.